Good morning, this is your Stats Sensei, Mr. Spensei, and we're going to run a complete hypothesis test. So, a company that manufactures smartphones developed a new battery that has a longer lifespan than that of the traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is skewed. That's important. With a mean of 30 and a standard deviation of 8. Okay. So we have a population mean of 30 and we have a standard deviation of 8. That's probably important information. The consumer tested a random sample of 60. That's important. It's random sample, and we have a sample size of 60 of these batteries and obtained an average battery life of 28. So from the sample, we ended up with an X bar equal to 28. Now, we can notice that our 28 is less than the 30. Test the company's claim of 30 months at a 5% level of significance. All right. Now, what it doesn't say is whether or not it's less than or not. This is a mistake on my part. I want test to see if it's less than 30 months. All right. Test to see if it's less than 30 months. So that didn't say that. It should have. So HO mu equals 30. That's the claim, months. And HA mu is less than 30 months. And once again, that's a typo on my part. I should have included that. The parameter, let mu equal the true population mean. Well, what do we care about? Battery life. All right. The conditions. Well, we need a random sample. Well, they told us it was a random sample. And they said it was a random sample of size 60. So 60, and that was given. I need to check. I need to check to make sure that the N is less than 10%. So N equals 60, and 60 times 10 equals 600. And I should be reading through there, and I should mention a population, but it doesn't. Since it doesn't, we're just going to have to say that it's less than the true number of cell phones. All right, that's not typically going to happen. That's me having left something off. Number 3, the third thing is normality. So N equals 60, which is greater than 30. So that means it's normal by CLT. The formula, Z equals X bar minus mu, standard deviation divided by the square root of N. So that's good. We need to draw a picture of this. When we draw a picture of it, we said that that was the claim, so that's what mu is, but we ended up with an X bar of 28. And we're going to shade less than because that's what the author, me, intended. So our mu was 30, our X bar was 28. I have to look back. Our standard deviation was 8 months. Our sample size was 60, and we shaded to the left. All right, so the next thing we need to do is plug in our information, and our information is going to go like this. We want the probability that Z is less than 28 minus 30 over 8 divided by 60. All right. So stat, test, Z test. Stats is highlighted. Mean is 30. standard deviation is 8. X bar is 28. N is 60, and we need a less than. And we end up getting Z, so we have the probability that Z is less than negative 1.9364, and that probability is 0.0264. And we're supposed to test this at an alpha level of 0.05. So our 0.0264, alpha 0.05, well, this is less. Make sure they're the same length. So 264 is less than 500. So we're going to reject the null. So, in conclusion, our p value is 0.0264. Our decision, we reject the null. What did we find? We found there is enough evidence, so it is sufficient evidence at alpha equal 0.05 to suggest that the true population mean cell phone weight, cell phone battery life because that's what it was, is, what did we say our alternative? Less than 30 months. All right. Thank you for watching. I hope this helps and look forward to seeing you on the next one.